Hi, everybody. Thank you for watching this video in lieu of class time. This section is on P.4, which is our last section in our preliminaries chapter. A really important section on factoring, something that we're going to be needing to do throughout the entire semester. So in P.3, we sort of like expanded polynomials, looked at multiplying them out. And so this example that I've got here, we kind of went like from the left side to the right side with using like foiling or double distributing to get rid of the product of these two binomials. And in factoring, of course, we're going to be going backwards. So looking at writing some kind of polynomial like this as a product of two things, right? Like here we can factor the right side into the product of these two things, x plus 3 times x minus 2. The way that the polynomial looks is going to sort of dictate what method that we're going to use. So I'm going to list out just a general strategy for factoring in general for any polynomial, and then we'll go through examples of the different strategies that I'll list here. So the first thing you want to look for when factoring anything is a GCF, which is a greatest common factor. And if there is one, then factor it out. If there's not, then you just move on to the rest of the strategy list that I have here. So once you look for a GCF and take it out, if you have one, then you want to factor what remains. And what you do depends on how many terms that you have. And remember, we talked about what a term is the last time in P.3. So this is the pieces that are separated by plus or minus in your polynomial, including just numbers by themselves and powers of x with numbers attached to them, right, coefficients. So if you have something that has two terms remaining after you take out your greatest common factor, there's only one way that this is factorable, and this is if it is a difference, so minus, of two perfect squares. And so if this is the case, so a difference, right, minus two perfect squares, something squared minus something else squared, could be variables, could be numbers, or a combination of numbers and variables. This factors into really nicely the first thing that was squared. So in the way that I've written it, x was squared in our first part of the difference, then y was squared in the second part, and that goes in the second part of each parentheses. And then one of them gets a plus and one of them gets a minus. And if you're wondering like, why is that the case? Why does this factor into this? You can always sort of check your factoring if you were to FOIL out. So if we were to multiply these two, right, the first gives us x squared, the outer gives us minus xy, the inner gives us plus yx, or that's the same as xy. And then the last terms multiplied give us y times y with a negative, so that's minus y squared. And no matter what these are, the minus xy and the plus xy, those are like terms, your other coefficients, -1 plus 1 is 0. They cancel out and you just get x squared minus y squared, right? And we're going backwards from foiling, so we want to go from this to this, and so that's how that will factor. If you have a sum of two squares, like if this were plus or anything other than a difference of two squares with two terms and no GCF, it's not factorable. So that's the only thing for two terms. And we'll go through examples of all of these in a minute, just like I said. So three terms, there's sort of two cases to look for if you have something with three terms. And the first is if you have something squared with a 1 in the front of it specifically. So I'll just use x1 x squared plus some number times x to the first plus some other number. So x squared plus bx plus c. The way to factor this is by doing what I call reverse FOIL. And I'll tell you what I mean by that. It's probably something you've done before. You look for numbers that multiply to c and add up to b. and then that'll tell you what numbers you use in your factorization. If you have something that's x squared plus bx plus c, but in the front of the x squared, you've got a number. And we normally use a to denote that, but this number here is bigger than 1. So, like 2x squared plus 4x plus 1, something like that. Reverse FOILing doesn't work in the same way, so you have to use what's called the AC method. Again, we'll go through examples of that in just a minute. The last number of terms that we have a specific way to factor is with 4 terms. And this, the only way to factor something with 4 terms, which may or may not work in general, so I'll just put try here, you try factoring by grouping. And anything larger than 4 terms, there's no like kind of easy technique to factor, so we'll stop here. Okay, so let's go through some examples of first factoring out a GCF. And just to remind you, this GCF here is just shorthand for greatest common factor. So we got to have the greatest thing that is common factor to all of the terms. So something that divides all of the terms. So number 1, we have 4x squared plus 8. Now you can look at the numbers first. So 4 and 8 in each of the terms, or 1, 2 terms here, and look at the powers of x separately. So the 4 and the 8, right, those both are divisible or have factors of 4, and that's the biggest thing that goes into both of them. So the GCF here is just a 4. And when you factor out a GCF, you put the GCF in the front. Right? It's the opposite of sort of distributing or the distributive property. And then you have to open up a set of parentheses because we're sort of like taking out, right, like a 4, we're undistributing a 4 from everything. And in order to have a 4x squared, if we were to undo this and distribute the 4 back in, we would need an x squared here. And in order to have plus 8 left, if we were to bring this back in and distribute it, we would need a plus 2 in the second part of our parentheses. So this is factored in terms of taking out a GCF, which is the 4 here. And again, you can always check by just distributing back your GCF. If that's a little hard for you to see as sort of like undoing distributing, which is essentially what it is, you could also just sort of divide each of the terms by 4. And then here you'd cancel those and get x squared. Here you'd cancel those and get a 2. So that's where that comes from. Just don't forget to write the GCF in the front because the 4 still is part of the expression. It doesn't just disappear. So here's our factored form for that. And number 2, we have 3x squared minus 6x. Again, something with 2 terms. Here we have numbers of 3 and 6. So you look for the GCF, the biggest number that divides both of those 2 things, which is of course 3. And then both of our terms here have an x in them, and we have x squared and x to the first. The biggest thing that goes into both of those is the smallest power of x overall, which is, of course, this 1 here. So you could take out also an x along with your 3 and your GCF. So when we write this factored, we are going to take out the 3x, and then we open up a set of parentheses here. This is times. And again, you think about, okay, if I were to distribute this back in, I would need, to get in 3x squared, I would need an x to the first, right? You would add the powers when you multiply. And then to have minus 6x when we bring this back in, we would need a minus 2, right? So I think we'll have an x and then minus 2 left over. And you can check your work even mentally by just bringing this back in and seeing, do I get exactly what we had to begin with? Alternatively, like we did before, you could factor out the 3x and then divide everything by 3x, right? Those cancel. The x there cancels. You have x to the first, so you subtract the powers. Here the x's cancel. That gives you a 2. And so you have x minus 2 left over with the 3x out in the front. Okay, in example 3, we have 5x cubed minus 15x squared plus 5x. So we have 1, 2, 3 terms here. I know I gave you strategies for factoring something with 3 terms. Right now we're just looking at GCFs. So you look at the numbers first, just like in the previous 2 examples, 5, 15, and 5. Of course, 5 divides all of those, and that's the biggest thing that goes into all 3 things. And then we have x cubed, x squared, and x to the first. All of them have an x, so the biggest one that's common to all of them is x to the first. I know this is the biggest power overall, but you need it to be in common with all of them. And like there's not enough in this one or this one to take out a power of x to the third. So right, we write this factored 5x out in the front. What's left over? Open up a set of parentheses. Think about, okay, if I were to distribute this in here, to undo what I'm doing, I would need to end up with 5x cubed. So I need an x squared to remain, minus 15x squared. If I were to bring this back in, I would need to multiply 5x by a 3 to get the 15, and an x to the first to get the x squared. So minus 3x. And then here, this happens to be our GCF, right? Now, when we are factoring it out, we're basically, like we've done in the previous example, dividing by the GCF. And when you divide something by itself, you get a 1. And in order to get the 5x here, when I distribute this back in, I need a plus 1. So don't forget that. It doesn't just like disappear and go away, or you need to have this plus 1 here so that when you bring this back in, you end up with what you started with. Right, and alternatively, you could do the dividing thing, 5x, divide by 5x, divide by 5x. This gives you, right, x squared. In the middle, we have 3, x to the first, and then these all cancel to give you 1. So either way you want to think about it is good. I hope one of them makes sense to you, but there's that factored form. All right, one more example with this to illustrate to you that a GCF could be a binomial instead of a monomial. So in this example, we've got x squared times x plus 7 plus 3 times x plus 7. Now I know this looks kind of complex compared to the other ones. The terms aren't as sort of like separated out like they were in the previous example, but you want to look at this as being like one part, and then we're adding this other part to it, and look for the things in common for each of those. So you look at anything that's multiplied within each of these sort of pink boxes that I've got here. So we have 3 multiplied in this second box, and there's really like a 1 here. So there's no numbers to take out. X squared, that base is x. I don't have an x multiplying anything over here, so there's nothing to take out with that. But then I have this same thing of x plus 7 and x plus 7 that's being multiplied in each of the boxes. So in this case, the GCF, like I said, is a binomial of x plus 7. So when we factor this, we're going to put the x plus 7 in the front. We're like undistributing it from here and here. And what's left over is basically what's in front of the x plus 7, right? We're going to like basically divide this by x plus 7, which will cancel it out. Same thing over here. Cancel it out, and we've got just x squared and then plus 3 remaining. So that's what's in the second set of our parentheses. And that's it. I know that, I don't know, that looks a little odd to do, but we will need to kind of recognize this GCF as a binomial when we look into factoring by grouping and the AC method. Okay, so let's move on to our next factoring technique, which was with 2 terms. And the only thing that we know to factor things with 2 terms is if we have a difference of 2 squares. So I'm just going to write the formula up here. Again, we had it as x squared minus y squared, and then it factors into x plus y times x minus y. So number 1, we have x squared minus 9. Now, clearly the x squared matches up, right? That's just x squared. And then 9, it helps know our perfect squares, right? That's 3 squared. So we want to think of this as x squared minus 3 squared. So that when we factor this, we will have two sets of parentheses multiplied together, binomials. The x goes in the front or the first part of each. A 3 goes in the second part of each. One gets a plus, one gets a minus. Really doesn't matter the order. I just stick with it like this. And so this is our factorization. That's all you got to do. If you recognize the difference of two squares and you know the formula, it factors into exactly that every time. All right, number 2, we've got 4x squared minus 25. Now I know 25 is 5 squared, 4 is 2 squared, x squared is x squared. But I want to be careful here with what is actually being like squared in the first part. Because although the square is on the x here, this 4 has to come into play, right? So we need like something squared, and it's not written in this way. So definitely the x is in our parentheses here, but then 4 is 2 squared. So really what we have with 4 times x squared is parentheses 2x, whole thing squared, right? And then 25 is 5 squared. So when we factor this, it is a difference. It is of two perfect squares. We'll have a 2x in the beginning of each factor. We'll have a 5 in the end of each factor. One of them gets a plus and one of them gets a minus, right? And that's it. 2x plus 5 times 2x minus 5. Right, number 3, we have 18x squared minus 50x to the 6th. Now these don't look like perfect squares, right? 18, 50, neither of those are in our list of perfect squares. So this is the first example where we're going to make sure that we look for a GCF, which I haven't been mentioning throughout, but we do want to do that first. So always GCF 18, 50, biggest number that goes into both of those. I don't know, they're at least even. So if I divide them by 2, let's just think about that. This would be a 9x squared. 50 divided by 2 is 25x to the 6th. And I don't think 9 and 25 have anything else in common. So a 2, I think, is the biggest thing that goes into each of those. And then each of these factors also has an x in them. And the biggest one that's common to both is squared. So our GCF is 2x squared. We want to start by taking that out of everything. Okay, so when I divide by 2x squared, to bring this back in and end up with 18x squared, I would need a 9. And then to end up with 50x to the 6th, if I bring this back in, I would need a 25x to the 4th. All right, now what I have left over here is a difference of two terms, and 9 and 25 are perfect squares. So I'm going to look at this as 3 squared. And then just like in our other example, right, I need to think of this as like something in parentheses squared. And I've got x to the 4th. X to the 4th is x squared squared. And 25 is 5 squared. So really what we have there is parentheses 5x squared, whole thing squared. So when I factor this, the 2x squared will stay, right? That's like done. It's still part of our factored expression though. And then the difference of two squares here is going to be split up into two other pieces where we have a 3 in the beginning, a 5x in the end, and one of them gets a plus and one of them gets a minus. And that's it, right? Once you end up with like something as x to the first, in any kind of thing with a binomial like this, where that's your biggest degree, you're done factoring. But definitely take a look and see if you can go further. But I think that that's it. All right, our last example here is x to the 4th minus 16. So no GCF. Right, we've got a 1 in front of the x to the 4th. There's no x power with the 16. It's two terms. It is a difference. I see this 16, that's 4 squared. And x to the 4th, just like in our previous example, right, we can look at that as x squared squared. So when we factor this, we will have two terms, two binomials with two terms each. The first one will be x squared. Excuse me, I'm so sorry. The second one, the second term in each will be a 4, and one gets a plus and one gets a minus. All right. Now, again, you want to always like to factor completely. Here I've got a sum of two perfect squares, right? 4 is a perfect square, but I've got a sum with plus. Here I've got a minus of two perfect squares. So this is never factorable. So this is a sum, I guess I should say, of two squares. So not factorable ever. It's broken down. It's as far as it can go. But this is a difference of two squares. So this is going to be split up further, but in our factorization, the x squared plus 4 is just like at its simplest terms. But x squared minus 4 will become x plus 2 times x minus 2. Right, and then once we get into like x to the first, and that's as far as we can go. So here's our fully factorized form of x to the fourth minus 16. Okay, so moving on to polynomials or things that have three terms in them. One method of factoring is what I would call reverse FOIL. So this only applies to things that have a 1 in front of the x squared, very specifically. Like example number 1. We have x squared plus 9x plus 8. Now, remember that when we were looking at multiplying polynomials or and binomials specifically, we can always factor these things into two binomials where we have an x in the beginning of each of them, and then we will have some numbers plus or minus in the last part of these. So if we were to sort of think about what happens when you multiply binomials, we do first, outer, inner, last, and the last things here and here, they need to multiply to the c value, right, or that number that's alone here. So we need two numbers that multiply to, in this case, what we have is positive 8. And then when we combine like terms, we get the middle term from the outer and the inner, the 9x. So not only do those numbers need to multiply to positive 8, but they have to add up to the b value. So we need two things that multiply to 8 and add up to 9. And it's easiest to start with numbers that multiply to the thing that you've got. So, we've got 8 and 1, we've got -8, -1, 2 and 4, -2 and -4. And the only two of these that will add to 9 is positive 8 and positive 1. So the way that we factor this will just be plus 8 plus 1, and that's all we got to do. If you wrote plus 1 and then plus 8, that's fine too. But that's the reverse FOIL method for factoring trinomials of this form, specifically with a square on the x and a 1 in the front of that. So I'd suggest you pause this video, try number 2, but I will go through this just like number 1. So this has the same sort of format, right? We've got a 1 in the front of the x squared. All we got to do is know that we have this format. It's going to factor into two binomials like so with an x in the front, and we need things that multiply to positive 20, and the sign goes with the b value and the c value, but in this case they need to add up to -9. So 20 multiplies 4 and 5, -4, -5. We've got 1 and 20, -1, -20, 2, 10, -2, -10. And I think that's it. But the only pair here that adds to -9, right, is -4 and -5. So we just do -4, -5, and this is our factorization. Right, and you can always check if you were to FOIL this out, right? X, I didn't do this with the first one, but you could always undo this and see first gives us x squared, outer gives us -5x, inner is -4x, last is positive 20, right? These combine to give you -9x. And that's exactly why we're looking for the -5 and the -4. right from here so that they combine to give us that middle term. All right, on number 3, we have 3x squared minus 6x minus 24. Now this does not fit the form because we have this 3 in the front. But I noticed that there's actually a GCF, right? So a 3 divides 3, 6, and 24. And so we should take that out first so that we get a 1 in the front of the x squared. So this will have a 3 in the front, and then we'll have an x squared. 6x divided by 3 is 2x, and 24 divided by 3 is 8. Now this fits the form we've got, right? So we're going to look for some numbers that will multiply to -8, and then add up to -2, and this will split into 2 binomials, x and x. And let's see, multiply to -8. Oh, we've got to have opposite signs, right? So 1, -8, or -1, +8, 2, -4, -2, +4. And the only two of these that add up to -2 are 2 and -4. So we've got +2 and then -4. And again, with that GCF of 3, still needs to hang around in the front. So here's our factored form of that. All right, number 4, that's so far down. We've got x cubed minus x squared minus 30x. So this one doesn't fit the form because it's cubed, but every single term here has an x. So again, GCF here, you can take out an x to the first. So let's do that to start. What we have remaining, we'll just reduce every x here by power of 1, right? So x squared minus x minus 30. Now we have to look within here, and this does fit the form of 1 x squared. And so we want to look for things that multiply to -30. And there's really a 1 here, so they need to add up to -1. Right, so I'm going to open up parentheses here. X goes in the front of each. Multiply to -30, got to be opposite signs. So 5, -6, -6, +5. There's a bunch, right? 2, -15, -2, +15, 1, -30, -1, +30. I think actually the first one I wrote here, right, you add these up, 5 and -6, these add to -1. So those are the numbers that we're looking for. So we've got +5 -6. And this is our factorization of that. All right, I think I've got one more here. Okay, all the way down there. So here we've got 14 plus 5x minus x squared. Excuse me. So this does not look like the form that we have. I mean, almost, but we do want the x squared to start, and we want a 1 in the front of it. But the way that it's written, I can write these in, add them in any order. So I'm going to put the -x squared first, plus 5x, and then this 14 is positive, so I'll do plus 14. But this negative in the front makes it so we can't do this process. So I'm going to have to take out a -1 as sort of a GCF, which is just going to change the sign of everything in the parentheses. So we'll have positive x squared minus 5x minus 14. Now this does fit the form that we're trying to factor, so we'll look for numbers that will multiply to -14 and add up to -5. And if you want to list those out, you can. I think the pair that we're looking for is 7 and 2. -7 and +2 will add up to give -5. So this factorization will have -1, or just simply a negative in the front, and then times x minus 7 times x plus 2. Okay, so before we do the second case with 3 terms, we have to understand what factoring by grouping is. So let's skip ahead to 4 terms first. Right, that's what I said that factoring by grouping applies to. So let's look at an example with number 1. We've got x cubed plus 3x squared plus 4x plus 12. So we've got, right, 1, 2, 3, 4 terms. No GCF among all the 4 terms, right? When you've got like a 1 in the front of one of your terms, and there's no x in all of your terms, there's no GCF. So how does factoring by grouping work? Well, you group the polynomial into two groups of two. And normally if it's written in like standard form with decreasing power order like this, then you can just group them first two and second two. And you look for a GCF within each group. So in the first group, we've got x to the second as our greatest common factor. And in the second group, we have a 4 as our greatest common factor. So two groups of two. And then find GCF within each group. Then you factor out the GCF in each group. So in the first group, we'll take out an x to the second. And just within these two terms, when you factor out an x to the second, you're left with x plus 3. And then in the second group of two, we'll take out its GCF of 4. And we've got a plus 4 here, so that still stays as plus. And then we have an x plus 3 left if we were to divide everything by 4. Then if this method works, what's in the parentheses here is going to match. So the next step is to then factor out the overall GCF of the entire thing, which will be a binomial, two terms, right? X plus 3, x plus 3. So what happens is the x plus 3 comes out undistribute, right, as GCF. And what you're left with is basically what's in front of each of the two sets of parentheses. So x squared and then plus 4 is going to be in our second set of parentheses. I know it's kind of hard to see, right? But if you just think of this as being distributed, multiply by the x squared, but don't kind of just write it as x squared times that in parentheses and don't bring this in. Same thing with the 4, just think about this as being multiplied by the 4, you'll end up with this. And so we do end up with what we began with. And now this is fully factored because we have a full product of something times something else, which we did kind of have over here, but we had like a plus. So we had thing plus other thing, and that's not factored, but this is, we have thing times other thing. Now often this won't really be able to be factored further. Here we've got two terms, sum of two squares, not factorable. Here we've got x to the first, and so that's not factorable either. So here's the factorization of this. Okay, number 2, we've got 2x to the third minus 6x squared minus x plus 3. All right, so this is written in standard form with decreasing power. There's no overall GCF, so we'll try factoring by grouping since there's 4 terms. So in the first group, our GCF of 2 goes into 2 and 6, and then x squared is our biggest power of x that you can take out. Now, something that happens with factoring by grouping that we need to be careful of is if this is negative here, if the first sign of your second group is negative, then you have to include the negative in your GCF of the second group. So with these two, our GCF is 1, but we got to take out a negative 1 here. And you'll see why when we factor out the GCF of each, right? So it's a second group, second step. We're going to take out a GCF of each group. So in the first, we'll take out a 2x squared, so we'll have an x left over, then minus 3. And then our GCF of the second group is negative 1, so we'll have minus, and then 1. Right, and we're thinking about undistributing this in, so we're basically dividing out a negative 1, so everything's going to change the sign. So instead of minus x plus 3, we'll have positive x minus 3. Right, and maybe now you can see that if we were to only have taken out a plus 1, then this would be minus and plus, and we need these two to match in the parentheses so we have an overall GCF. So the way to fix that is to take out a negative with your GCF if this sign right here is negative. Okay, so then overall GCF here of x minus 3, so that's going to get its own set of parentheses, or we're factoring it out as an overall GCF. So we're dividing this piece and this piece by x minus 3. It goes out in the front. And what we have left is 2x squared minus 1 in our second factor. Now, often these aren't factorable further, but actually the first that's done. Here we've got a difference. 1 is a perfect square, but 2x squared is not. So here, there, that is in factored form. All right, so I'd encourage you to pause this video and try number 3 on your own. But we have, again, a 4-term polynomial, 6x cubed minus 9x squared plus 4x minus 6. So first group of 2, looks like our GCF is a 3x squared, and our second group of 2, 4 and 6, has a GCF of 2. Okay, so we write this with the GCF of each group of 2 taken out. 6x cubed, take out the 3x squared, divide it out, we'll have a 2x left. And 9x squared, divide out the 3x squared, we'll have a 3 left. Now this is a plus here in the front, so we don't need to take out a negative or anything. We'll just factor out a 2, so we'll have plus, and then 2 times, 2x minus 3. It should be left if we divide those two terms by 2. Okay, now this and this match, so factoring by grouping is successful in this case. So we'll take out the overall GCF of 2x minus 3. And then in the second factor, we have, again, what was multiplied by each of those. So 3x squared plus 2. Now, none of these are factorable further, so this will be our final factorization. All right, last example here, 12x to the 5th plus 20x to the 4th minus 21x cubed minus 35x squared. Now here, there is an overall GCF first to take out, although there are 4 terms. We always want to look for a GCF of everything. X squared for sure is something that could come out of everything, and then anything else? So with the numbers, let's see, 35 is only 5 times 7. 7 does go into that, but 5 goes into this, but I think 12 doesn't have a 5 or a 7 in it. So it looks like our GCF is just x squared. So let's first factor that out of the entire expression. So this will just reduce every power of x by 2, right? We're kind of dividing, so we subtract the exponents. Okay, then within our leftover piece here, we've got 4 terms. So we'll look at these 2 groups of 2, factoring by grouping GCF of each group. In the first group, we've got a 4 as the biggest number that goes into 12 and 20, and then an x squared. And in our second group of 2, a 7 goes into both, but we've got this negative in the front here, so we've got to take out a negative 7. Right, then this x squared is just like kind of just coming along for, it'll keep carrying down. Big parentheses here. In our first group of 2, we'll take out a 4x squared. It looks like we'll have a 3x plus 5 left. And in our second group, we'll take out a negative 7. That's going to change the sign of everything. Negative 21x will become positive 3x, and minus 35 will become plus 5. Again, these match here, so factoring by grouping is working. So the x squared again comes down. We're going to take out the 3x plus 5 as a GCF of the overall thing in the big parentheses, and then we'll have 4x squared minus 7 left. And that's it, right? We've got a difference here, but 7's not a perfect square. So there it is, fully factored. I actually don't need these, big parentheses here. We can just sort of write these next to each other, and there's our factorized version of what we started with. Okay, so our last factoring technique is going back to polynomials that have 3 terms in them when you have an x squared, and the number in front of it is bigger than 1. So not 1, basically. And if it's negative, we'll have to take out the negative to start. So for example, 4x squared plus 37x plus 9. Right, number in front of the x squared is not 1, and we can't factor out a 4 to make it a 1 because of the 37 and the 9 are not divisible by 4. So here's the way to go about the AC method, and I'll write the steps over on the right as we go through it in this example. So it's called the AC method because we take A times C. So in this case, right, this is A. It's just the numbers without the x with their sign. So A is 4, B is 37, and C is 9. So we do A times C, which in this case 4 times 9, which is 36. Okay, then you need numbers that multiply to that product, which in this case is 36, and add to B. So here's where we use the positive 37. So numbers that multiply to 36 and add up to 37, which is only 36 and 1, right? These are going to add to 37, which is B. Okay, then once you find those numbers, you split the middle term, the BX term, using them. So in reverse FOIL, you just take those numbers and they go in your parentheses, but this is a little longer. So you take the middle term here. So now we're going back here and we're saying, okay, 4x squared, that's left alone. Positive 9, that's left alone. But the plus 37x, I'm going to split that up into plus 36x plus 1x, or just plus x. Now what we've done is we've made our trinomial into something with 4 terms. So how do you factor something with 4 terms? You use grouping. So once you have split up your middle term, the last step is to factor by grouping. So first 2 terms and second 2 terms. First 2 terms have a GCF of a 4 and then x, and the second 2 terms have a GCF of a positive 1. So we take out the 4x from the first group of 2. That leaves us with x plus 9. We take out a 1 from the second group of 2, which leaves us with x plus 9, right? And then by factoring, by grouping, these have to match. That's our overall GCF. So that comes out in the front of everything. And what we're left with is essentially what was in the front of each of the x plus 9s. So the second factor is 4x plus 1. And this should always work if you do it right. By construction, this x plus 9 in this case should be the same. If not, then something went wrong elsewhere. So that is the AC method. So try number 2. Again, I'd encourage you to pause this video and try this on your own. But I will go through it just like number 1, right? So here's A is 5, B is -6, and B is -7, and C is -6. So A times C is 5 times -6, or -30. And we're looking for numbers that will multiply to -30, but add up to -7. So I don't know, we've got 6 and 5. We've got 15 and 2. Those aren't 7 apart. What else have we got? 10 and 3 add up to multiply to 30, and those are 7 apart. So 10 and 3, one of them has to be positive, one of them has to be negative because they multiply to be negative, and they've got to add up to be just -7. So it looks like the 10 has to be negative. So when we add these, right, we get -7 overall. Okay, now we take what we started with and we split up the -7x into -10x and plus 3x. Then I still have the -6. right? So it's just that this middle term here is just becoming these two terms. And it doesn't matter if you maybe did plus 3x minus 10x. It doesn't matter the order, you'll get to the same result in the end. All right, so for terms, we do factoring by grouping. Here our GCF is 5x. Second group of 2, our GCF is 3. So taking out the 5x from the first group of 2, we've got x minus 2. Taking out the 3 from the second group of 2, that leaves us with x minus 2. Right, looking good, these match. And so we put in the x minus 2 in its own set of parentheses, right? We're factoring it out as the overall GCF, so there's just 1. And what's left over in the second set of parentheses is what it was multiplied to in the beginning. So 5x plus 3. And that's it. Once we get to x to the first like this in our factorizations, then we can't do anything else. Okay, let's try one more example of this together. And it is 3x squared minus 16x plus 5. Okay, so AC method candidate for sure. This is a 3 in front of the x squared. 3 can't divide out, so we've got to use this method here. So 3 times 5 is 15. We need numbers that multiply to 15 and add up to negative 16. Okay, so, 15 and 1, right? But negative 15 and negative 1 are the numbers that add to negative 16. Okay, so then we take those numbers and we split up the middle term here into two terms, right? Negative 16x is the same as negative 15x minus 1x, and the first and last terms always just come down. All right, now we have 4 terms here, so we will factor by grouping. First 2 terms have a GCF of a 3x, and the last 2 terms have a GCF of a 1, but because this is a negative in the front of our first term in our second group, we've got to take out a negative 1. Okay, so the first 2, take out a 3x, we'll have an x minus 5 left. Second group of 2, we factor out a negative 1. Everything's going to change sign in the second group. So instead of negative x plus 5, we'll have positive x minus 5. Okay, now the x minus 5 is the overall GCF of our entire expression. So that gets its own set of parentheses. We factor it out in the front. And then in the second factor, we'll have 3x minus 1. Okay, and there is our factorization. I haven't been checking these, but if you wanted to FOIL them out and see that you get back to where we started, that's always an option for you to check your work. But that is for now the important factorization techniques that we will need for the course. So please try your web assignment on this, come to office hours with questions, try your written homework, and have a great day. I will see you soon.